I've got 30, which obviously is 60/90, and this is 325. Do I have enough information? Brandon, you're the math whiz. Do I have enough information to compute that triangle? This is 325, 30, 60, 90.
Yeah.
I can get this, I can get the hypotenuse, which I don't really need. What I'm looking for is I know this z location, do I not? All I've got to do is calculate this side opposite to 30, and then I add it to this z, and that gives me my z location for the start point of that radius. Everybody working with me? Everybody still with me?
I'm just trying to see where 325 came from.
The 325. At least the man is honest enough to ask a question. Thank you, Corey. I have this diameter is on the print, and it's. I'm going to try to recreate. Now, matter of fact, I'm just going to do this. This diameter is a known. It's on the print. It's 1.400 diameter. This diameter is on the print, and it's 0.750. I got two choices to get this in a radial dimension. I can half both of these and subtract this one from that one, or I can subtract this one from this one and then divide it by 2 to get the one side. I'm going to draw that in different colors. One of these days, you'll get guts enough to ask a question. And this will all make sense. Thank you, Corey. Guys, I know because if I take somebody, let's do math. It's easier for me to take the 1.4 minus the 0.75. That gives me the diametral difference between these two diameters. I simply take that and divide it by 2 to get the radial distance on one side of 325.
Why divided by 2? Why the 2?
Because otherwise I'd be getting the diametral difference.
Okay.
There's 650 thousandths difference from this diameter to this diameter. We're struggling with excuse me. We're struggling with radial versus diametral.
So we were at 900 in Z.
We were at 900 in Z.
And so then you would subtract
You would add
the
side opposite to 30.
18.187.
Say that one more time. Did you already do the calculation?
0.1876. So it would be 1,876.
It'd be 1 inch.
Yes, I'm sorry.
If you got 187, we're going to add that to the 900.
Right.
I'm going to call it 7, 8, 1.087 is the start point of that radius.
Why would you round down?
Pardon me?
Why'd you round down?
Because I figured he rounded to get there. That 187 is 3/16 of an inch. It's a normal number. By all rights, I should have rounded up. Because if it was 187.6, you're absolutely right, I should have rounded up to 88. If you can find that thousands after you run my part, good luck. I should have rounded up. Okay. Guys, this is the math side of it. This is what we're having to do to get, before we can ever program, we got to figure out what dimensions are on our print and what dimensions are not. It would have been just real nice if they'd just give us an X and Z location to the start point and end point of that radius, wouldn't it?
Where did we say X was?
X was 1 inch, 150 thousandths.
I thought we added or subtracted or added the 1275. Right there in front of you to the left. Yeah.
We added something. We added that 125 to this
Right.
to get to the 1275, which is actually this x.
Of the point
Yeah, the one we're looking to program to.
is 1275.
Yes, sir.
Okay.
Nope.
So our next line would be x 1.275 z minus 1.088.
Yes, sir.
Okay.
That is our next point that we put down right over here is x. Not working out for me. X is 1.088 and z minus, what do we come up with?
No. X is 1275.
I'm sorry, z is 1.088. X is 1.275.
Yeah.
My bad.
You know what would help, I think, just if you would put that slash that some people do on your Z through the middle.
This little guy here.
Yeah.
Everybody seeing those as twos?
Yeah.
I thought X was 1.4.
1.4 is the end point. 1.4, look on your print. Look at the diameter that's 1.4.
Of letter L.
1.4 is up here.
Yeah.
That's your final diameter, the biggest OD of your part. We're having to go to the start point. This is the calculation we're doing.
We're doing K.
It's the one kicking that kicks butt. Now the nice thing about this is we've got all the numbers to do our next point from the calculations we just finished. Grant.
How come it's 1.275 and not 1.150? You got both of these ones right there.
The 62.5 thousandths. The 1.150 is to the center of the radius.
Okay.
The side opposite, the 30 degree, is 62.5. Doubled for diameters gives us, add the 125 to the 1 inch 150. It probably would have helped if I'd have put the .125, add those two together. There's your 1.275.